Dear students, now we are going to study about warehouse scale computer to exploit request level parallelism and data level parallelism. Basically, warehouse scale computer is nothing but interconnection of several servers and then desktop computers in a large scale. So that is why we are going to use warehouse large scale computer. The service provided by warehouse computer is to connect with internet services for each and every people they are going to use. What all the services provided by basically with along with internet services is to search in a Google thing information and for in order to have an email for social networking, online mapping, video sharing, online shopping, cloud computing, etc. So these are all the services basically provided along with that warehouse scale computers. So if you want to compare that warehouse scale computer along with existing infrastructure like high performance computer clusters, or otherwise if you want to have data center, this is the comparison. So the clusters have high performance processor and the network. Whenever we are going to use the cluster emphasizes thread level parallelism, whereas warehouse computer will perform request level parallelism. That is a basic difference between that high performance cluster as well as your warehouse scale computer. Apart from that, in the clusters we have very minimum number of desktop as well as server, whereas in case of warehouse we have more number of servers as well as desktop computers that are interconnected. If you want to compare that warehouse scale computer versus your data center, it consolidates different machines and software into one location, and then we have virtual machines and hardware heterogeneity in order to serve various customers. But there is one more comparison also we are going to have along with that warehouse versus data center. Traditional data center will work on single organization, whereas warehouse scale computer work in multiple organization. That hardware as well as software will be in homogeneous environment, whereas in case of warehouse scale there is going to be in heterogeneous environment. Request level parallelism, in the title in that information it is given request level parallelism. So for request level parallelism, the best example we can go for Google search. That will we have any request, it will can be posted and then it will give you the information. What are all the responsibility of request level parallelism is, if you want to have hundreds of requests, it can be done within a second. Requests are largely independent. We have to have independent requests, we can post and then we can get that information. Mostly it is involved in read-only database. Already it is stored, we can read that information from the database. We will call it as producer consumer sharing. So the consumer, whenever we want to have any information, we will post and then whoever is having this information, they will produce that information along with the request. So rarely we will go for read-write sharing or synchronization across request. So if you want to update or otherwise any other information you want to put it into that database, that is also possible. Computational is easily partitioned with a request across different requests. So if you want to have a partitioning and then it is also possible. So if you want to have request level parallelism along with that warehouse, we have to have some innovation is required. That is, we have to concentrate on power distribution, cooling or monitoring, and we have to have several individual operations. What are the design factors for warehouse scale computer is, the first one is we are going to concentrate on cost. How much work they are going to be completed within that particular one single dollar, that is a cost. Maximum number of things has to be settled down within one single dollar. The second design factor is energy efficiency. So energy efficiency means how we are going to distribute that power based on power consumption. Not only that power consumption, what are the cooling mechanism that is going to be concentrated for in order to calculate the energy efficiency. That is the second design factor. The third design factor is the dependability via redundancy. What is basically dependability? So if you want to have long running nature in internet services, the hardware as well as software has to provide less than 99, at least 99 percentage of availability to provide internet service. That is called as dependability. It must be at least less than 1 hour per year. That server or otherwise whatever that infrastructure we are going to have, it should be down at least one very minimum amount of 1 hour. So if you are going to use multiple warehouse, along with that we have to reduce the latency of the services provided. If you are going to post any service or request, at that time the latency has to be minimum. Apart from that earlier design factor, we are going to consider that design factor like network also. How you are going to interface along with that external world, the performance, how effectively that IO is going to work for in order to connect with external world. And then one more design factor is parallelism. So the parallelism we are going to have is based on data level parallelism, which is going to be stored in storage instead of data memory. Normally you all know, if you are going to access through memory, the latency is going to be high, whereas if you are going to have a parallelism along with that registers, that latency is going to be minimum. So in that case, that processing has to be done based on the storage, which is going to be in register or otherwise memory. We are going to consider that one operational cost, that is also one design factor. So the operation cost is depends upon the performance. We are not going to worry about either any other power or otherwise infrastructure management. That cost is purely depends upon the performance of that particular machine. We are going to have that design factor not only for the performance, how that scale, so how you are going to upgrade, and then what are the factors of which has affect that upgrade, that is also going to be considered as a design factor. So if you are going to have that scaling, if you are going to have large volume, automatically the cost is going to be reduced. What are all the programming models which are going to be supported by warehouse scale computer? Basically, warehouse scale computer will run a batch application. Basically, batch application is not run. Batch application is nothing but we are going to consolidate everything that is going to be run one by one without any human intervention. The process going to be done is, so for example, we are going to convert that video into new format. So in that case, there will be step by step procedure will be given to that batch, and then it is going to complete that process. For if you want to do batch processing framework, that method which is going to be used is called as MapReduce method. So MapReduce, a map is nothing but a programmer going to supply a function for each and every logical input record. It is going to be run on thousands of computers, or we can say in this manner, it is going to be distributed among several computers with the help of that function that is going to give intermediate results. That provides new set of key values for intermediate values. It will give you each and every process, each and every server is going to process that information based on the function given, and then it will give you the intermediate results value. The role of reduce is, it will have also that function that is going to be give that collect all those things, and then it will give you the result. So map is nothing but we are going to have some intermediate record that is going to be give you the result. If you want to get detailed, we can refer to this diagram for MapReduce philosophy. So in this diagram, if you are going to have one application, there will be the first one is called as masked instant. The masked instant, it is nothing but it is partitioning that input into a multiple segment. The role of master instant is take one application, divided into multiple segment, that is going to be grouped into several segments. That is going to be called as input data. That is given as input for map instant. The role of map instant is read the data from that input data from that segment, and then it has to process the data. That is the role of map instant. So again I will repeat, the role of map instant is it will read the data from the segment and then it has to process the data. The processing data is going to be stored in a local disk of that server. That is going to be done by map instant. So map instance, it will store that information. After processing based on the function, it is going to be stored in local disk. Now coming to the second part, reduce. So whatever we have discussed is the part of map. The second part is reduce. The role of reduce is to insert read that data from the local disk and merges that partial result. So it will collect all the results, intermediate results, and then it will group, and then it will make as a partial result. The final results are stored by reduced in the shared storage. The reduce instant collect that information after going to the sequence, and then it is going to store the result in a storage. Once that process gets over, again come back into that map instant, that will check for the report whether that process is completed or not. Once if it is complete, it will terminate the operation. So this is called it as MapReduce philosophy. So MapReduce is nothing but, first you have to divide that input data into multiple segment, and then based on the map function you process, and then you have to store it in a local disk, and then the reduce will get the intermediate results, do some function on that one, and then finally we are going to store it in a storage device. Finally the map instant, it will check for correction. If there is no further correction, then it will terminate that process. Take one simple example. In this example, we are going to take a particular document. In that particular document, we are going to get the number of English words we are going to identify. So in that, how many English words are available, we are going to get the final result. So for that, we are going to use that function called MapReduce function. In that, map is going to be one part, reduce going to be one part. So for that, these are all the keywords are going to be there. The key is nothing but that is going to be assigned for a document name. Document name we are going to give, and then value is nothing but the size of the content document, the number of words is going to be there. So we are going to have one function, already we discussed in a map or reduce, we will have some function. The function is nothing but emit intermediate word. Whenever there is an English word which is going to be available, we are going to emit, and then we will have one count for those values. It will produce the list of intermediate results. So this is going to be done in multiple servers. That is the ultimate aim of warehouse scale computer. We are going to distribute the task into a multiple scale. In that multiple servers, this process is going to be done. Once that process gets over, the role of reduce, it will get that word and then list of counts. Initially it is going to be Z0. We are going to perform one parse invert. What is that here is, all the things are going to be string. We are going to convert that into a value. Based on that we will add, and then again we are going to convert that into string. Then it is going to be displayed. So this is one simple example for MapReduce that is going to be took part in this warehouse scale computer. So the aim is, if we are going to have one application, in that case that warehouse scale computer will help you to distribute the task, and then we are going to get the results with a minimum latency. So MapReduce, this is the slide will give you information about the MapReduce usage at Google over a time. So we have a number of job, and then what will be the completion time, what will be the input data size, what are the size of that intermediate data, what will be the size of output, and then average number of servers which are involved in order to complete that process. So that month wise they are given that what is that what are the results available for each and every function. So now up to now we have discussed about the fundamentals as well as basics which are related with warehouse scale computer. How that warehouse scale architecture is. Already I told you in the beginning, warehouse scale computer is nothing but it is a collection of a desktop as well as server which are going to be connected. So we have a hierarchy. Based on the hierarchy of network, the interconnection is going to be done. For example, if you take one simple architecture, if you take 19 racks, normally if you warehouse scale computer, we will say that vertical racks, we will have vertical racks. In that case, there are 48 servers connected to a rack. Each are connected to a switch. They are going to rack switches are uplink to switch hierarchy, higher in hierarchy. So each and everything will have a bandwidth that is depends upon the port. So maximum goal is to maximum the locality of the communication to relative to the rack. If you are going to have an architecture based on warehouse scale computer, what are all the things we will get? What will be the end result? So we'll have storage. So maximum storage from a hardware perspective, it includes inside the server. For in order to store that information, it is rely on internet connectivity. So connection that each and every server is going to be rely on Ethernet connectivity. So if there is an alternative, what will be the alternative? So for that we are going to use an alternative for in order to store that information is nothing but network data store is NAS is a method which is used for in order to store that information. So what will be the technique? So this is the infrastructure is available for in order to store the information. The technique which is used to store that information will be called as RAID techniques to improve the dependability of the storage. So we will have array switch that connect an array of racks considerably more expensive than Ethernet switch. So for in order to have the dependency as well as dependency reliability, we are going to use array switch for in order to have connection among those switches. So the networks which are major users of field programming. Not only that, why? Because we are taken from the FPGA for in order to have that for connection between several servers. So latency. So if you are going to store the data in a memory, we have several kinds of memories available. One is called as SRAM, one is called as DRAM, or those things. So in that case, what will be the latency? What will be the time duration for in order to store the data? For that, in this chapter, they are given some logical information for in order to store that information. If you are going to have server can access the DRAM, if I am going to use method DRAM, dynamic RAM, and a disk on other server using a new style interface, that is connection information is based on UMA style interface, and what will be the time? So the steps, what are the parameters they are taken? The latency, disk latency, DRAM bandwidth, and the disk bandwidth, what will be the capacity, and then what will be the capacity for disk also. So the conclusion is, what will be the time duration, what will be the maximum bandwidth among the disk versus DRAM for in order to store that information. So whether we are going to store locally or otherwise we are going to store it in rack, and then what will be the array size. This is the information we will get in this one. So finally, before going to conclude this lecture, we are going to have one infrastructure diagram. So this is the information, this is the diagram which will give you how the connection establishment is going to be there. So there is a layer 3 network which is used to link arrays together along with that internet. So the role of conventional layer is to connect the arrays together to the internet. In most of that application, we will use only single array within the warehouse scale computer for in order to have the connection establishment along with that server as well as for internet connectivity. But rare cases, we will go for multiple arrays also. There is also possibility for in order to have sharing as well as partition. Meaning that why we have to go for multiple arrays is if the data is going to be splitted into multiple segment, if there is any dependency or there is independent requirement, we have to distribute it in different other ways. Otherwise, single array is more than sufficient for in order to process with the help of warehouse scale computer along with that function MapReduce. So the conclusion is, in that internet IoT environment, if you have more number of devices going to be there, it will produce large volume of data. In that case, if you want to process, we have to have some infrastructure like warehouse scale computer. In that, we have to use some method called MapReduce method for in order to do that process efficiently with the minimum latency period. That is the conclusion for this particular topic. I hope you have got the information about warehouse scale computer. Further, you have any doubts, you can post me anytime and then I will give you the answer. Thank you.